Okay, so good morning everyone. Here I am again. So I'm sharing my screen with you. I'm adding two more examples for our enthalpy. So the last one was already in our first video, which was enthalpy, and thank you for viewing the video and the other videos as well. I'm adding two more. This will help you in solving your assignment for thermochemistry. At least after this video, you can actually validate if what you did was correct, and you can redo if there should be some parts which are incorrect. So I'm just giving you two examples. This will be a very short video. I just really want you to guide you on how to solve those problems. Okay, so if there should be questions, please uh, note them down, and then we'll have them during our face-to-face, or you can message me in FB or the big blue button in Canvas. So let's have the first example. It says here the heat of fusion of pure silicon is 43.4 kilojoules per mole. Let's move me. How much energy would be needed to melt a 6.32 gram sample of silicon at its melting point of 1693 Kelvin? Actually, what we're looking for, the required is, I think I don't have my pencil yet. Okay, the required will be energy. Here it goes. So we're looking for energy, and that's, you know, that our energy is synonymous to our heat, synonymous to our enthalpy. So in this case, but first let's try some unit conversions. This is a very simple problem. All you have to do is really analyze the problem, check out the given in the problem, and you may not be able to use any formula, just do a conversion. Okay, let's just use an empty slide because I need this here, silicon. So the material is pure silicon. What we're given in the problem, I think the heat or the energy, it's for silicon, it's 43.4 kilojoules per mole, right? That's given in the problem. What else? The mass is actually 6.32 grams. Let's look at that again. Yes. And there's a given melting point. So at temperature, it's, if I'm not mistaken there, it's a 1693 Kelvin. So, but something new is in this problem, which is mole. It actually talks about what? That mole talks about molar mass. So in doing or computing for molar mass, you have to know or understand that element in the periodic table. If it's a compound, you have to get all the elements in the compound and get what? In the periodic table, we isolated silicon and you see different numbers. Okay, you have to check this one because that will be the atomic mass. Okay, let me talk about the atomic mass that we use for in computing the molar mass. So it's a pure silicon, which means there are 28 grams per mole, or for every 1 mole of a silicon, it's 28 grams. Okay, so let's just do some energy conversion. You might just really end up with that energy which is required in the problem. So let's start with what's given. We're given 43.4 kg per mole. And as I've said, we rely on this. We have something here, 28 grams per mole. So we know that in conversion factors, if this is mole, so this is grams, so this is 28 grams per 1 mole. So we're getting rid of mole already. So we have a kg and grams. So what's next? Let's try to multiply what? We have given grams here. So we can actually just multiply 6.32 grams, right? And what do we get? That's grams, mole, mole. And guess what? You already have the answer. So it's just get your calculator, that's 43.4, but take note that's kilojoules times 6.32 divided by 28. I'm getting 9.796 kilojoules. Let's do that again. That's 43.4 times 6.32 divided by 28. That's 9.796 kilojoules. So that's our answer. So do you have questions about that? If there should be questions about it, please note them down and then ask me during our face-to-face, or you can message me via our messenger chats. Okay, so is that it? Is that what we're looking for? Yes, it's just looking for how much energy will be needed to melt a 6.32 gram sample of silicon at its melting point of 1693 Kelvin. Okay, again, I'm gonna do what I did, gonna repeat it. I tried to just summarize the given. So H, which is heat of fusion, the mass of a silicon, the melting point. Actually, the melting point doesn't do anything in the problem. It's just stating that it melts at 1693 Kelvin. And I isolated silicon from the periodic table, getting the molar mass. It's only 1 mole, so that's 28 grams per mole. So just do unit conversion, 43.4 kg per mole, that's 28 grams per mole. And then we're using a 6.32 gram sample. So that's it. So if we go, let's be consistent with the units. This is up there, down, down, up. So what we're left is 9.796 kilojoules. So this is our answer. Okay. So if there are questions, please note them down. Okay. Since I can't answer you right now because this is a video. So I'm doing the next example. The next example is very similar to it. It's just that it's not a pure element, but it's a compound. We're using acetone. So it says here, if 2 kilograms of water were vaporized to steam in a boiler, how much acetone in kilograms would need to be vaporized to use the same amount of heat? Where the given is the heat of vaporization for acetone is 31.3 kilojoules per mole for acetone. Okay. And acetone is given as C3H6O. So if you have a periodic table with you, or just Google a periodic table where you have to take note of the atomic masses of carbon, hydrogen, and oxygen. Okay. I'm going to do this step by step. The first step would be, please remember that's 2.0 kilograms. So we're using 2 kilograms. First things first, if you see a compound and the heat of vaporization is given as HV and it's in kilojoules per mole, so we have to really identify the molar mass. So what's the molar mass of acetone? So it's C3H6O. A while ago, I said that just rely on the nearest whole number. So we have 3 carbons. So 3 times, what's the atomic mass of carbon? It's 12. So, sorry, that's 36. And then we have 6 hydrogens. So hydrogen is 1. So that's 6. So this is carbon. It's hydrogen. And for oxygen, we have 1. We only have 1 oxygen there. So 1 times oxygen in the periodic table is nearest whole number, that's a 16. So this is 16. So if you add them all up, that's 58 grams per mole. Okay. Again, just isolate the 3 elements of acetone. That's C3H6O. So we're getting hydrogen, carbon, and oxygen here. And then just get the molar mass. Okay, what's the next step? Find the amount of energy required to evaporate the water. Yes, because you're turning water to steam, and you have to get that energy, and then use that same energy later on for acetone. So we're using our enthalpy equation, which is H equals M evaporate, so that's HV. Okay, you're always asking me questions like, ma'am, are we gonna use 2260? Okay, whatever is given in the problem. If the problem already has a table, like in this case, use the table. Now, if it's given separately or very specifically, this is the value of the specific heat or the latent heat, please use those values. So for this, we're getting the energy as, what's the mass of water? In the previous slide, 2 kilograms. So check also the units of your latent heat of vaporization. It's in grams. So make sure that when you plug them in the solution, you're also using grams. So that's 2 kilograms. So that's 2,000 times 2258. Okay, so that heat or that energy is equal to 2,000 times 2258. So that's 44,516. I'm getting 4,516 kilojoules. Okay, because I'm getting, if you have your calculators with you and you're following me, we're getting 4,516, and there are 3 zeros. Those 3 zeros are actually your kilo prefix there. Okay, if it's in this case, that's a joule. So what's next? What's the next thing to do? Of course, the last part would be to do what we did a while ago for silicon, but this time it's acetone. So we're using the same heat, and the same heat that we're getting is what again? I'm sorry, it's 4,516. So that's 4,516 kilojoules times. For acetone, the HV is 31.3 kg per mole. So let's just multiply that. Again, let's check that out again. It's 31.3. Okay, that's 31.3 kg per mole. So let's have that. Let's erase that because you have to use the reciprocal, because you have to try to cancel the unit. So it's 31. This is for acetone already. So it's 31.3 kg per 1 mole. What's next? What's the molar mass of acetone? We computed 58 grams per mole. So that is 58 grams. Oops, I think I did that. Okay. Let's see, where's my pointer? Okay. Okay. Let's get my pen tool again. It's 58 grams per mole. So for acetone, that's 58 grams per 1 mole. So if you're already trying to check if what you're doing is correct, mole, mole, kj, kj. And what's actually missing in the problem? We're actually looking for what? How much acetone in kilograms? So we're looking for the mass. We actually already derived it. So we're getting it here in grams. So that's 1,000 grams per 1 kilogram. So what is our final answer? If I compute that, that's 4516 times 58 divided by 31.3 divided by 1,000. We're getting 8.36. Oops, 37. 37. Let's raise that. Okay, doesn't want to be erased there, so I'll do that again here. So I'm getting 8.368. So as I've said also during our group chats or previous classes, I wanted to round off in the nearest 2 decimal places. So this is 8.37 kilograms. So this is the mass. Okay, let's do that again. This is the same energy. This is the energy that we obtained a while ago for water. And it says they use the same heat or use the same energy for acetone. So use that and then just do some energy conversion, unit conversions, so kilojoules. So this is what's given as heat of vaporization of acetone. So it's 31.3 kg per mole. And then just to cancel the mole, we're using the molar mass. It's 58 grams per mole. And then of course, finally, since what's required in the problem is the mass in kilogram, there's 1,000 grams per 1 kilogram. And then computing it, we're getting 8.37 kilograms. So that's our final answer. Okay, so these are the last 2 problems. So what you can do now is go to your canvas. If there should be activities that you need to redo or answers that you need to redo, I'm giving you the rest of the period to do your canvas activity. And if there should be questions, please don't forget to message me in our big blue button or FB. And by the way, you can share this video to your friends, ask them to subscribe so that they can use the same problems for the reviews and references. Okay, so for now, that'll be it. I still have one more video to upload. Please wait for it. And I'm going to see you guys in class. So, goodbye.